Welcome back to the Network Plus training series. In this lesson, we are covering Objective 3.2. Given a scenario, use network monitoring technologies. Monitoring is the eyes and ears of your network. Without proper monitoring, you are essentially flying blind, unable to detect problems until users start complaining. Let's explore the tools and technologies used to keep watch over network health. SNMP, or Simple Network Management Protocol, is the most widely used protocol for network monitoring. SNMP allows a management station to query network devices for status information and to receive alerts when problems occur. SNMP has three main versions. SNMP v1 is the original version with basic functionality and weak security using community strings in clear text. SNMP v2c adds improvements like bulk data retrieval but still uses community strings. SNMP v3 adds strong authentication and encryption and is the recommended version for production environments. SNMP uses several key components. The management station, or NMS, is the system that queries devices and collects data. Agents are software running on managed devices that respond to queries and send alerts. The Management Information Base, or MIB, defines the data objects that can be queried on a device. OIDs, or object identifiers, are unique numerical identifiers for each data object in the MIB. SNMP operations include GET, which retrieves a specific value from an agent. GetNext retrieves the next value in the MIB tree. Set changes a value on the managed device. Trap is an unsolicited alert sent from the agent to the management station when a predefined event occurs, like an interface going down. The management station typically uses port 161 for queries, and traps are sent to port 162. Syslog is a standard protocol for collecting and centralizing log messages from network devices. Log messages provide detailed information about events occurring on the network, including errors, warnings, configuration changes, and security events. Syslog uses port 514 and sends messages to a centralized Syslog server. Syslog messages have severity levels from 0 to 7. Level 0, emergency, indicates the system is unusable. Level 1, alert, requires immediate action. Level 2, critical, indicates critical conditions. Level 3, error, indicates error conditions. Level 4, warning, indicates warning conditions. Level 5, notice, indicates normal but significant events. Level 6, informational, provides informational messages. Level 7, debug, provides detailed debugging information. A helpful mnemonic for Syslog severity levels is, every awesome Cisco engineer will need ice cream daily. NetFlow and IPFIX are technologies for analyzing network traffic patterns. NetFlow, originally developed by Cisco, and its open standard equivalent IPFIX or IP Flow Information Export, collect information about network traffic flows. A flow is defined by a set of characteristics including source and destination IP addresses, source and destination ports, protocol, and interface. Flow data provides visibility into who is communicating with whom, what applications are being used, how much bandwidth each application consumes, and traffic patterns over time. Bandwidth monitoring tracks how much network bandwidth is being utilized. Tools like MRTG, CompTIA, or PRTG can graph bandwidth usage over time. This helps identify bottlenecks, plan for capacity upgrades, and detect unusual traffic patterns that might indicate security issues. Packet capture and analysis involve capturing actual network packets for detailed inspection. Wireshark is the most popular tool for packet analysis. Packet capture allows you to see exactly what is happening on the network at the packet level. This is invaluable for troubleshooting complex issues, analyzing protocol behavior, and investigating security incidents. Port mirroring, or span, on a switch is used to copy traffic to a monitoring port for capture. Environmental monitoring tracks physical conditions in data centers and server rooms. Sensors monitor temperature, humidity, water leakage, and door access. SNMP-capable environmental monitors can send alerts when conditions exceed thresholds. This is critical for preventing equipment damage due to overheating or other environmental issues. Performance metrics that should be monitored include latency, which is the time it takes for data to travel from source to destination. Jitter is the variation in latency, particularly important for voice and video. Packet loss is the percentage of packets that fail to reach their destination. Throughput is the actual amount of data successfully transferred. CPU and memory utilization on network devices indicate whether devices are being overloaded. Interface error rates track CRC errors, collisions, and other interface-level problems. Alerting and notification ensure that the right people know about problems as quickly as possible. Monitoring systems should be configured to send alerts through multiple channels, including email, SMS, and messaging platforms. Alert thresholds should be carefully tuned to avoid alert fatigue from too many false positives while still catching genuine problems. Escalation procedures define who gets notified first and who gets notified if the initial responder does not address the issue within a defined timeframe. Dashboards and reporting provide visual representations of network health and performance. Real-time dashboards show current network status at a glance. Historical reports help identify trends and support capacity planning decisions. Executive dashboards provide high-level summaries for management. Log management involves collecting, storing, and analyzing log data from across the network. A SIEM, or Security Information and Event Management system, aggregates logs from multiple sources, correlates events, and provides advanced analysis and alerting capabilities. Proper log management supports troubleshooting, security investigations, compliance requirements, and forensic analysis. Let's review the key monitoring technologies. SNMP provides device-level monitoring and alerting. Syslog centralizes log collection and management. NetFlow and IPFIX analyze traffic patterns. Packet capture provides detailed traffic inspection. Environmental monitoring protects physical infrastructure. Effective monitoring requires proper alerting, dashboards, and log management. Thank you for watching this lesson on Objective 3.2. In the next video, we will cover Objective 3.3 on network high availability.